Very good evening to one and all. Today I am here with Polynomials Part 2. So students, in Polynomials Part 1, we have studied the definition of a polynomial, degree, relationship between the quadratic polynomials and its coefficients. Fine. In Part 2, we are going to study the relationship between the coefficients of a cubic polynomial. Then we'll be learning how to find the zeros of a biquadratic polynomial. So before proceeding, just give a pause to this video and try to solve these questions that you have done in Part 1. Now we will find the relationship between zeros of a cubic polynomial. A general cubic polynomial is written as ax cube plus bx square plus cx plus d. This is my general cubic polynomial. So if I will say let alpha, beta and gamma are zeros of this polynomial, then what the condition we have? Ax cube plus bx square plus cx plus d, it is equals to k x minus alpha, x minus beta and x minus gamma. Now I'll simply multiply this k x square minus beta x minus alpha x plus alpha beta and x minus gamma. Then you have k x square minus alpha plus beta x plus alpha beta into x minus gamma. Now I can write k. Now if I'll multiply, I'll get x cube minus gamma x square. Then I have minus alpha plus beta x square and plus alpha plus beta into gamma x, and the last one is alpha beta x minus alpha beta gamma. I have simply multiplied these three factors. So now arranging the terms, I will get x cube minus, these are the two terms of x square. So if I take x square common, minus x square common, I will get alpha plus beta plus gamma. And then these are the two terms of x. If you take x common, then you have alpha gamma plus beta gamma plus alpha beta. And the last term that you have is minus alpha beta gamma. And on the left hand side you have ax cube plus bx square plus cx plus d. Now if you compare the terms on LHS and RHS, then the value of a came out to be k, value of b, it came out to be minus k into alpha plus beta plus gamma, value of c came out to be k alpha beta plus beta gamma plus gamma alpha, and value of d came out to be k minus k alpha beta gamma. Now see, if you substitute the value of k from this first part, you can find the value of alpha plus beta plus gamma. This will come out to be minus b upon a, sum of the zeros. And in this equation, if you will substitute the value of k as a, you will get the value of alpha beta plus beta gamma plus gamma alpha is equals to c upon a. And in this last equation, if you will substitute the value of k as a, you will get the value of alpha beta gamma, which is equals to minus d upon a. So the relationship between the zeros of a cubic polynomial, I have alpha plus beta plus gamma, it is equals to your minus b upon a. Fine. Then I have alpha beta plus beta gamma plus gamma alpha, it is equals to your c upon a. And the last product of zeros, it is given by alpha beta gamma, it is equals to minus d upon a. So the way we have done the relationship between the zeros of a quadratic polynomial, in the same way we can find the relationship between the zeros of a cubic polynomial also. If zeros of the polynomial fx is equals to x cube minus 3x square plus x plus 1 are a minus b, a plus b, then find a and b. So these are the three zeros given. Now as I know that the sum of zeros is given by minus b by a. So here in this case, sum of zeros means a minus b plus a plus a plus b. This is sum of all the three zeros, and it is equals to negative coefficient of x square upon coefficient of x cube. So negative of negative 3 upon 1. So from here you will get b and b will get cancel each other. 3 times of a, it is equals to 3, and from here you can write your a is equals to 1. After that I have one more part, product of zeros. So in this case, product of zeros means a minus b, a plus b. Product. It is equals to negative d upon a, means the constant term upon the coefficient of x cube. So the constant is 1 and the coefficient of x cube is also 1, so it is 1. Now from here you can write the value of a is 1, so if I substitute a is equals to 1 here, I'll get 1 minus b, 1 plus b, it is equals to negative of 1. So from here you'll get 1 minus b square, it is equals to negative of 1, and from here you'll get negative of b square is equals to minus 2, negative negative got cancelled, and your b is equals to plus minus square root of 2. So this is how you can find the value of b. Quotient is equals to divisor into quotient plus remainder is known as Euclid's division algorithm for integers. Similarly, this is called division algorithm for polynomials also. Now we can define it in terms of polynomials in this way, that if fx and gx are two polynomials such that gx is not equals to 0, then we can always find qx and rx such that fx is equals to qx into gx plus rx. This is something very much similar to this, only dividend is equals to divisor into quotient plus remainder. Here we have Rx equals to 0, or your degree of Rx, it is less than degree of Gx. This is how do we define a division algorithm for polynomials. We have this question: divide the polynomial 3x square minus x cube minus 3x plus 5 by gx, x minus 1 minus x cube, and verify the division algorithm. Fine. So first of all, we have to do the division that you people might have done earlier in class your 9th also. So let's divide first of all. The way we used to do, we will divide it in that way only. Minus x cube, I have written it in a proper format first of all, plus 3x square minus 3x plus 5. And my divisor is minus x cube plus x minus 1. So first of all, I'll divide it by 1. So I'll have minus x cube, then plus x and minus 1. On changing the sign, I'll get 3x square minus 4x plus 6. Fine. So this 3x square minus 4x plus 6, this is your remainder. Since this degree is less than this, therefore this is the remainder that I have. So here I will be writing the division algorithm. My fx is minus x cube plus 3x square minus 3x plus 5. Fine. And my gx is minus x cube plus x minus 1, and my rx is 3x square minus 4x plus 6, and your qx, it is equals to 1. So you can substitute the values over here. So what you are going to get, I'm writing the right hand side only. Qx is 1 and my gx is minus x cube plus x minus 1 and plus rx is 3x square minus 4x plus 6. So if we'll simplify it, you are going to get minus x cube plus 3x square, and this is plus x minus 4x is minus 3x, and 6 minus 1 is your plus 5, which is equals to your fx only. So this verifies your division algorithm, as well as you know the way to divide. Sometimes students make this mistake that they keep on dividing. So you have to keep in mind, the moment you get this degree less than the degree of the divisor, in that case you are not going to divide further. Fine. Our next example is find the zeros of the polynomial fx if two of its zeros are root 2 and minus square root of root 2. Now since it is a biquadratic polynomial, so it will have 4 zeros. Fine. 2 of its zeros are given. Now let me go with the solution part. We say that if x is equals to alpha is 0 of a polynomial, then x minus alpha is a factor of that polynomial. अगर x is equals to alpha हमारे किसी पॉलिनोमियल का 0 है, तो x माइनस अल्फा उसका एक फैक्टर होगा. तो यहां हमें दो जीरोस गिवन है, रूट 2 और माइनस रूट 2. इसका मतलब x माइनस रूट 2 एंड x प्लस रूट 2 आर factors of fx. तो यहां से मुझे if I denote it by gx, then my gx came out to be x square minus 2 is a factor of fx. Now since my x square minus 2 is a factor of fx, then let me divide this fx by gx. 2x4 minus 3x cube minus 3x square plus 6x minus 2. और यहाँ gx है हमारे पास x square minus 2. So let us divide this. We'll have 2x square first of all. It will give you 2x raised to the power 4. And this multiplied by 2, it will give you minus 4x square. Just subtract it. You will get minus 3x cube. And here you will be having x square plus 6x minus 2. Now I'll take minus 3x. So it will give me minus 3x cube and then plus this I'll be having here plus 6x. Again by changing the sign, this will cancel out. This will also cancel out. You have x square minus 2. Now just taking 1, you will be having x square minus 2 minus plus. So remainder came out to be 0. So the remaining zeros of this fx we will get from this quotient 2x square minus 3x plus 1. Fine. This is your qx. And remaining 2 zeros I'll get from here. So just by splitting the middle term, I'll get 2x square minus 3x plus 1 is equals to 0. So I'll be writing it as 2x square minus 2x minus x plus 1 is equals to 0. And from here you can take 2x common, you'll be having x minus 1. Minus 1 common, x minus 1 is equals to 0. So from here you will be having the factors x minus 1 and 2x minus 1 is equals to 0. So your values of x came out to be 1 and x is equals to 1 by 2. And the 2, those were given, they were root 2 and x is equals to minus root 2. So these are the 4 zeros of the given polynomial. Fine. So let me tell you once again, if we are being given with a biquadratic polynomial and they'll give me the 2 zeros of that. So first of all, I'll just multiply those 2 factors and I'll get a gx, I'll get x square minus 2. So now this gx is a factor of this fx. That means on dividing fx by gx, I'm going to get remainder as 0. And whatever the quotient I'll get the remaining zeros from the quotient only. So on solving the quotient, I'll get these 2 zeros, x is equals to 1 and x is equals to 1 by 2.